Here we go. So, I saw that this was put on Cracking the Cryptic recently, and I do not know whatsoever what this is. I was simply saw that it said that I will be stunned by it. So I'm going to do is I'm going to refresh, and I'm going to I'm going to clear cookies and refresh. Well, apparently it keeps my time. I don't know why. I haven't done anything with it. There we go. So, what are the rules? They're just going to repeat within a cage. Normal. Digits in each cage sum to a square number. Okay. Cells separated by a white dot must contain consecutive digits. There are 9 hidden zeros in the grid which count for 0 for the purpose of cage sums and white dots. Okay. They appear once in each row, column, 3 with box. Consists of all digits 1 to 9 once only. Hidden zeros may not repeat within a cage. Okay. So that means that I could get this equal a minimum of 10, because I could have a 1, 2, and a 0 hiding somewhere. But because this is a minimum of 10, then that means I have to go to 16. So this is a minimum of 9. Then I could go 25. 25 would make that 18. Okay, this is going to be too many different values to consider. I mean, 18 would mean that this doesn't have the 0 in it. There has to be a hidden 0 in each area here. That could even be a hidden 0. That'd be pretty funny. Actually, if that's a hidden 0, yeah, so actually, this could be as low as 9. It could be. Yeah, it could be 9. Interesting. Well, first things first. We know that those are the same. And if this is a hidden 0, that doesn't have to be a hidden 0. We know they're the same value. Purple somewhere down there. Not necessarily. Yeah. That's all the information I have about that. It's not super helpful. Besides, those are the exact same values. I don't have too much else. What do I know? It has to spill from a cage. It has to spill from a box in order for this to be helpful. Well, these sum to 3 cubes and add to 45. Or 3 squares and add to 45. So if they add to 45, I could do 4, 16, and 25. And I think that's the only way that can be done. 4, 16, 25. 36, 9. That's doable. 25, 16, 4. 16. How do I get to 45? It'd be what, 29? Do another 16, 13, no, 9, 20. I could do like 16, 9, 4, and that would work, but not for this cell. So I think this has to be 25, 16, 4, because I can't do 36, 9, 0, because you need a 1 cell in order for that to be correct. Yeah. So 25, 16, 4. 9, 8, 7 makes 24, so that has to be the 25 cage, which means this adds to 18. Which means this adds... This could be 16, and that could be the 4. In theory. Oh, but you could have smaller numbers, though, depending on what's missing. Oh, because of what's missing, this doesn't actually... So yeah, these cages don't actually add to give you 45. They actually give me less than 45, depending on what the empty value is. Okay, that's screwy. Wait a second, this is the cells of 45. This adds to 45. That still adds to 45. All those cells together, but they have to sell some to a something. So we know that the 9 must be the empty value in here. Whatever it is, the 9 must be the empty value in here. And it's not... Actually, it could be this. These could both be 9. That's an empty value, and that isn't. No, so they both have to be empty values. If this is an empty value, this has to be, because none of those are. So yeah, these share empty valuedness. But they can't be the same number, which means these can't be 9, because if these are the same number, then yeah. So these are the same number, and they share empty valuedness, because if this is an empty value, none of these can be, but one of these had. Oh no, but that doesn't have to be. Yes, it does. One of them has to be, and because 45 doesn't sum correctly, so these would have to be the same. Yeah, so these would both have to be the same number and have the same empty valuedness, which means these cannot be the empty value. Okay. Progress. I've already made a little bit of progress. I've not watched Cracking the Cryptic's video on this. This sums to less than 45, as long as this isn't the... Yeah, because this could just be 36 and 9. But yeah, since we know that 9 has to be... I'm just going to put a 9 like this, since you know that this can't be a 9, and we know the empty value has to be in one of those, we know that none of the other areas can have 9 as their value. Which means, since 9 cannot be their value, then we're not targeting for 36 total here. So we're working up from that. 37. Can you do 37 as the sum of 3 squares? 36, 1 something. 25 gives me 12, doesn't work. 37 minus 25, 37 minus 16 gives me 21. Nope, doesn't work. So 37 isn't correct. Gotta do 38. 38. I take 36 away and get 1, 1, but that wouldn't work with these cells. Yeah, so this is 37 if the 7 is the empty. It could be 25 gives me 13. 13 can be 9 and 4. So we've got 25, 9, and 4 would work for that. At least that. 38 minus 16 is 22. 22 doesn't work. Right? 22 minus 8 is 14. Doesn't work. Okay, so now we go to 39. Can we do 39 as the composition of 3 squares? That would be if the missing value was 6. You can't do 25. You can't do 30. So yeah, you can't do 36. Can't do 25. So you get 13. Sorry, you get 14. And 14 isn't the sum of 2 squares. Actually, let me just do... What can... Okay, let's start with the sum of 2 squares. I can get 2 if I do 1, 1. See, I'm just going to write them all down on a notepad here so I don't forget. I can get 2, which is equal to 1 plus 1. It's going to sound kind of stupid that I'm writing that. Then next I can go up to 5 is equal to 1 plus 4. And then I can get 8 is equal to 4 plus 4. And then I can get 10 is equal to... oh yeah, this is for ignoring the zeros, obviously, but is equal to 9 plus 1. Can I get 11? No. 12? No. 13 is equal to 4 plus 9. 14, 15, 16. I can get 17. 17 is equal to 1 plus 16. 18 is 9 plus 9. 19 doesn't work. 20 is 4 plus 16. 21 doesn't work. 22 doesn't work. 23, 24, 25 does actually work as 9 plus 16. That's where I'm going to leave it for now. Okay. So, okay. This is a doozy of a puzzle then. So 39 is 45 minus the 6. 39, I can't, so 13, no. 19, no. 17, no. 18, no. 26, no. 29, no. 31, no. 34, no. 37, no. Okay, but I can do 40. 40 with the 5 being chosen, I can actually do. Because that is 36 and 4 and 0 would work. 25 would be 15. 9 and 6 would not work. So it would have to be 16. So 40 would be 16 is 24. Oh, it's not doable. 41 is doable. No, is it even? Okay, 40. Yeah, no, I don't think 40 is doable. Because you take away 16 from 40. 16 from 40 gives you 24. I can't make 24 nicely. So I take 25 from 40 to get 15, which doesn't work. 36 to get 4 doesn't work. So I go lower. So I go lower. So instead of 16, I go 9, gives me 31. 31 doable? No. But if I do 41 as my base number, then I can do 25 plus 16 plus 1 gives me 42. Yeah, 25, 16, 1 is 42. But 41... Can I do 41 at all? I don't think I can. Minus 36 gives me 7, doesn't work. 41 minus 25 gives me 16, doesn't work. 41 minus 16. Ah, no, it does work. It's 9, 16, 16. So I can get that. And 42 works. So right now I'm looking at 7, 4, or 3 being the empty number. And I'm going to take a wild stab in the dark and say 45 is the only other value that I could have. Which doesn't work. But let's still check it anyways. Can I do 43? 43 minus 36 is 9, which I can't do in 2 different numbers. And I can't have any of them be equal to 0, so that wouldn't work. 43 minus 25 is 18. Ah, fuck. 25 plus 9 plus 9. 44. Okay. So can I do 44? Minus 36. Nope. 25 gives you 19 isn't doable. So 25. We go down to 16, which gives you 28, which I can't think of numbers in my head that would work for. Subtract 9 from 44. Nope, not doable. Okay, and we can't have 45, obviously. So, we have 7, 4, 3, or 2 as our values. If we have 7 as our value, then we need to make 25, 9, 4. Well, 25 would have to be in one of these columns if the 7 was being excluded, and we cannot create 25 using only 3 digits, which means 7 is not our 0, which means this is solid. Now we have 42 by subtracting the 3, so we need 25 like this, then 16, then 1, which we guarantee that this would be the 1-3 pair, which make that a 2-4. Let's just go through this process right now. Be a 1-3, this is a 2-4. The 0's already being used. Yeah, the 0's already being used for the 3 in this case, because we're having 25, 16, 1. So this has to equal 16. So it has to equal 14, so it would be 9, 5, 6, 8. Or it equals... That's 14, or it equals 12. Which, okay, actually, let's do that math. If this is a 2, what can these numbers be? Sorry, if this is a... Yeah, if that's a 4, what would those numbers be, rather? Because this has to equal 12 now. Can't be 9, 3. Can't be 8, 4. Could be 7, 5. No, it can't be 7, 5. Which means that can't be a 4, which means that has to be a 2. Okay. And now we can continue from here. So this would be 14. And it can't be 7, 7, so we've got 8, 6, 9, 5. These then have to add up to give us 25. So this is 25 minus 7 gives us 18. Well, 4 plus 5 plus 6 plus 8 plus 9 is 32 minus 18. Yeah, okay, yeah. So we've got all the other sets of values here. How does this line up nicely? Well, if we need... Yeah, it would just be whatever we don't use here would all be left over here. But we would guarantee that this is a 4. There's a 4 there. That's all that we know. And that our blank value is somewhere there. But we... So this is a theoretical line that does have a valid solution. Let's get rid of that. So, 3 being it, I'm going to put an asterisk that I can think about it later. So, now we have the 4 being excluded. We have a couple different lines to explore. It would be 16, 9. That being 9 is a little restricted, isn't it? Yeah, so it would be 9, 9, 16 that we'd be working with. Yeah. In order for us to have our 4 asterisk. So if that's a 9, that could be 1, 2, 5. No, it could be 1, 3, 5. Could be 1, 2, 6, or 3, 5. There we go. Those are the possibilities that we have. This guy has to equal 9 because we can't. I mean, it could be 16, couldn't it? It could equal 16. Okay, so let's see if we can exclude anything else. Getting rid of the 2. We have 25, 9, 9. This has to be the 25. Because if it was the 9, that wouldn't work. No matter what. So this has to be 25, so that's 9, 9. Can you make 18 in 5 numbers? Yeah, you can. You only have 3 degrees of freedom, though. So this has to include the 9, which we already knew because it's 25. So 7 plus 9, 16. The other 2 values need to add up to give you 9. And then we have the other 9s left over here. And then then we have the 2 somewhere in there, probably a 2 and it can't be a 2 and a 9, so the 2 would have to be here. So then we have these add up to be a 9, these add up to be a 9, these add up to be a 9, and then that works out. Well, these minus, except for the 9, add up to be 9, and that should all work out. These are adjacent, so that could be like a 3. If that's a 2, that's a... Or no, if that's... It's alright. If it's adjacent to that, then it has to be a 0. Oh. Yeah, okay. I could have actually... I made a mistake. Let's go back to the Okay, I just realized. Let's go back to the 42 example, because I forgot about a 0 for the purpose of cage sums and white dots. Which means if we go back to this example of 1, 3, either, since we know that 3 is the example that we're using for this, this is either a 1, in which case this has to be a 2, or it's a 3, which means it's a 0, which means that's a 1. But it can't be a 1, which means, because it can't be a 1, that has to be a 2, 1, 3, and that's what we have to work with. We don't have any choice. Okay, so that makes things a little bit more interesting. These have to be adding up to 14. So, this adds up the rest. Yeah, so this actually guarantees a little bit here. And that says that that is the empty one. In this case. If that's correct. But I'm not sure if it is, of course. Huh. Okay. I'm going to abandon this line for now. I've got another thing I'd like to explore, which is this area here. It's 2 cells that add to give us, well, they all have to give 45 minus some amount. So I want to look at all of the possible ways to do it with 2 digits, or with 2 different values. I'm going to start with 36 and climb up, so there's going to be a bit of a gap in my logic. But 36, I don't think, can be the sum of 2 squares. 25 and 11 doesn't work. You can't have one inside be 0. 16 plus 20 doesn't work. We've crossed the threshold. Because the other one would have to be too high. So 36 wouldn't work. 37 minus 36. It could be 36 and 1. No, it can't. It could be 25 and 12. No, it can't. And then we're going to cross the threshold when we go back down to... well, 16 makes 21. Yeah, wouldn't work. 38. 38 minus 36 would be 2. Doesn't work. 25 from 38 gives us... Nope, not going to work either. And until we get to... 16 plus 25 is 41. So until we get to 41, it's not going to make a difference if we go down to 16. No, we have to get to 50. So I can only just take away 25. So one of them has to be a 25 cage or a 36 cage. So 36 doesn't work with 39. 25 cage does not work with it either. So this has to be 41, or 40 or 41. Because 40 is 36 and 4. But that doesn't work because we can't make these cages add up to 4. 41, on the other hand, is 25 plus 16, which fits what we're looking for. 42 wouldn't work. 36 plus... No, yeah, so 41's our answer. So it has to be 25 and 16. Which means the value we're missing there is a 4. Okay. So... this cannot both be... So yeah, so we know that in here, the missing value is a 4. I don't know how to mark that. Oh, there's actually... they have a little 0 here thing here. We know that the 4 is the problematic number here, which means it isn't in our previous example up top, which means now we have this down to 2. It's either a 2 or a 3, if this one's a 4. So I'm going to put that somewhere down here. Just to know that the 0 is the 4 in this box. I'm just going to highlight that as green as we figured out the number. We don't know what the number is here. For sure. Actually, no, we do know what the number is for sure. We know it has to be 9. So this is 0, 9. I mean, it has to be in one of these cells, so that one's solved as well. We don't know what this value is, because it doesn't matter. It can be literally any value, and all we know is that it has to both be right there. We also know it also has to be down here. Hey, we have another one here. We've got another thing here. So this one could be 40 is equal to 36 plus 4. And then in which case there'd be 5 missing. Because it could be like a 5, 1, 3, and that would work. And specifically, this can't be 41 because this one was 41. It worked the same way. So it has to be 40. Since it has to be 40, we know that this is 36, this is 4. This needs to have the missing number, and it has to be a 5. So this is going to be 5, 1, 3. And these are all the other values. 2, 4, 6, 7, 8, 9. Well, these can't obviously be 7. Yeah, we have 4, 5, and 9 now officially be numbers. Okay, I'm starting to see how this is going all cluing in here. But now that we know that, so we still don't have a 2 or a 3 be our options. 2 was a possibility here, with this being a 9, this adding to 25, or 18 rather, and this being 9. We can't have, well, where would the 2 be? The 2 would have to go somewhere in here. On the right side, this has to be the 25. If I take that away, we have 18. If I take any of these away, it doesn't work. So the 2 can't be here, which means it would have to be here, which means the 4 would have to be there. Is there any issue with that? Well, so it's either there or there, no matter what. Which means the 4 has to be here. Because either we have a situation where this top left cell is, or where the top left box has a 3 as its missing number, or 2 as its missing number. And if it's a 3, we know it has to go here. And if it's a 2, yeah, and we know that this has to be the missing number over here. If it's a 3, it has to go there. If it's a 2, it can't go there either, which means we're here, which means we've covered 2 of the columns, and it cannot be here in any of those cells no matter what. So then we know that this has to be where our 4 is. So, should put that in. That's a 4 somewhere there. And none of these can be 4s. Cool. What else do we have? Well, not much. If we're gonna let's do the math out again of it being 2 that we're working on. This is 25, which means that's 1899. So 1899, 2 can't be there, which means either the 9 goes here and there's a 2 there, and then these add up to 9 normally, like 139 or something like that. Or, well, actually, if this was 139, yeah, if it was 139, yeah, if it was so it'd be 13529. I don't think that's possible, because we have to shove the 123 here. Or, the 135. So it's 13529. Then all the 135 have to go here, because 135, again, guaranteed there, has to be there. So it can't be 135, so it would have to be 126. We're going to operate off of the idea... Oh, but it can't be 2. Which means the 2 can't be in here. Which means the 2 has to be here. By this logic, at least. Which means this sums up to 2 numbers that make 9. That sums to make 2 numbers that make 9. This has the 9 in it. So it could be like, well, what numbers add to give us 9? We have a bunch of different options of numbers that add to give us 9, but... Well, what numbers can be down here? We haven't guaranteed any other numbers over there now, because of the weird screwery we were doing. This is now been half an hour since I started, roughly. So I know... Okay, let me fix this as well. We know that one of those is correct, and we know that none of these are. So we know that the right number has to be somewhere over here. That the 0 has to be somewhere there. And it has to be 99, or 16, 1. Those are the options. In every case, this adds to give us 25 correctly. So we have to make 18 with 3 numbers. $198. There's a lot of ways to do it. Crap. Okay, where do I want to go next? These all have to be 1, 4, 9, 16. That it can only be 1, 4, 9, 16. Those are the only things it can be. For this, yeah, 1, 4, 9, 16. 1 if it's a 1 or a 1 and a 0. 4 could be 1 and 3. 9 could be anything. 16, yeah, 1, 4, 9, 16. Those are the only options. Okay, so given that, what is this? What does this add up to? Well, we can't have more than 1, 1 in theory. So either this is the 0, or all of these are, or one of those guys are. Let's operate on the idea that this is not. These are not the 0. We need to make. Oh no! What am I doing? I'm having difficulty figuring out exactly what to piece together here. Could this be 25? In theory, if I have 45 minus 9 minus 8 minus 7, I get 21, which means I do have the flexibility of making that 25 or 36. Depending. I just thought about that. With those, we have the 7 highest, the 7 lowest digits we can work with is 1 to 7, which is 28. And then we could have a 3 excluded, and that would work. But we have a couple degrees of separation there, a couple degrees of freedom, rather. So with that, yeah, because it could also sum to 39, in which case you could put or 37, or 36, which means you can put virtually anything anywhere. Anywhere else. That's irritating. Yeah. Well, we know that neither of these are those are the same number and not the 0 number. Let's match with one of these. Is this every number? No. 1, 2, 3, 4, 5. It is not every number. Damn it. And since we don't know which one the 0 number is, we can't pinpoint any further than we already have. My hands are watering. I don't know why. Oh, and since this is here, we know that none of these can be. Yeah, we already know that none of those can be the digit. You know that none of these can be the digit. That one of these is the digit. Progress. Little incremental progress. 013 is doable. These are two squares added together, and they add to less than 45. If this sum to 25, that has to be 9. No, it doesn't have to be. There's just two. Yeah, if that adds to 25, no, because it could be adding up to 36, but then with the fake on that. This is so tricky. I don't know where to move to next. Wait, no, it can't be the 9 missing. If this is 20, okay, if this adds to 25 air quotes, then the highest it can actually sum up to is 35. Yeah, this is 25, then we have to have the 8 in here. In maximum world. 1 plus 2 plus, whoops. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equals 28. That's the highest that you can sum one of these cells up to. And then you'd have to be missing the 3 to make it 25. But then you'd have the other ones be 8 and 9. Well, that could be a 9, and that could be an 8. So it could be 9, 8, all the numbers 1 to 7, with a 3 missing, and it works. Do it again with the 4 missing. Do it again with the 5 missing. You work all the way up to 7. Which is increasing the numbers 1 by 1. Oh, wait, no. Oh, yes, it would, because you just swap out whatever digit you're... Yeah, the 7, 6, 5, 4, which is dumped all the way down here. So it would be... Yeah, so if it's 3... The missing number plus this adds to 11 in that case. Because this would have to be 9. Interesting. And then the rest is 25. So it's 25 plus those make 9, make 36 plus the 9. So this is either 1, 4, 9 or the 0. Those are the options. So those are my options I have at the moment. This is tricky. Put the 0 somewhere there. That one of them is a 0. But I don't know what the 0 value here can be. It can be anything, I think. Huh, I'm not sure what step to take here. I've gotten a lot of, like, the heavy work done, where I know that this has to add to 16, period. Well, what does this have to add up to? Didn't we establish that this is 41, this is 25 and 16? That means this has to add to 16. So that's 16. This is 18. 34. But then we add 4 because the 4 is somewhere in here. And this adds to 38. So the minimum of these could be is 2, 6, 7. Plus 2, plus 6, plus 7. Minus 45 is 8, which means, since this could be a 7, 8 otherwise, this has to be an 8, 9 pair. Though that's the only 2 values it could possibly be in order for it to add up correctly. Because this has to be 16, it means plus the 4 means it has to add to 20. We know this adds to 18. 20 plus 18 is 38. The minimum that we can have here, 38 plus 2 plus 6 plus 7, gives us 53. It should add to 45. So all of this, we have 8 more than 45. But then we could also have this go from 267 to 268, could be 1 higher. So it's a minimum of 8. Because if we bump this up, then these values have to be bounced down. This value goes down by 1, this value has to go up by 1. Yeah, that's an 8-9 pair. Cool! So now that I know that this adds to 16, and at minimum 8, that means that this can't contain a 9. Okay. Can't contain an 8 either. Could this contain both 8 and 9? Maybe. But yeah, so this adds up to 8. So it could be 7, 1, and that would work. So let's just check it for a sanity check. 8 plus 7 plus 1 plus 4 is 20. That means the rest of that to 25. That looks right to me. Oh, wait. 135. So if I make this 135 plus 2 numbers that add to 16, so has to be 97. If I do 13597, these have to be 135, which they can't be. So this can't be 13597, which is one of the ways to build 25. So it can't be all odds. Which means this can't be all evens. Which would have been 2 plus 4 plus 6. Plus 8 minus 4. Yeah, that would have worked if those were all odds, but that doesn't. So there has to be that would have been all evens. This has to have an odd number somewhere in it. Which means there needs to be 2 odd numbers within it. And since this is a... Yeah, so there has to be 2 odd numbers within this area here. There has to be 2 even numbers here. If there's 2 odds, there has to be 2 evens here. It means there's 3 evens in this area. Those are all odds. Is it going to be an odds-even problem, I wonder? I feel like it could be. Could 1 and 3 be here? In the possibility that that's 1, 3, that's 1, 3, then 1, 3 has to be here. Well, it needs to add, so it would have to be 1, 3. Yeah, because it adds to 16. No, it can't. 1 and 3 can't be there. So if this is a 1 and 3, then that has to be 1, 3, and the 1, 3 has to be over here, but we already know there has to be a 4 here, and that has to be a 0. 9 plus 1 plus 3 gives us 13. We don't get enough to make 16. So this can't be a 1, 3 pair. If that can't be a 1, 3 pair, then we know that 42 is wrong. So we know for a fact that this has a 2, 0 pair. That whatever the 2 is, whatever the 2 is the 0 here. So could this be 2, 9? Possibly. If that's 2, 9, that's an 8. This shit over here. But yeah, so now we know. Okay, so you've got 2, 4, 5, 9. Progress is being made. Yeah, because if this was a 1, 3, which it has to be if it's as we showed before, if there was if the 3 was the value, that has to be it. That would turn that into a 5, those into a 1, 3, and then this has to be 1, 3, which doesn't work. So yeah, we need to have the 2 here, be it. So that means we're looking at a 2599. So this adds to 1899. Could be a 2-9 pair here. Is there a reason why it can't be a 2-9 pair here? I don't see any reason why it couldn't be. Not off the top of my head. And then we have 3. Well, if this was a 2, this has to be a 1. Then it has to be. So this can't be a 2. So it would have to be. Okay, let's walk it through. If that's a 9, so it has to be 9, 2. If that's a 2, 9 pair has to be like this. Because otherwise a 2 would be up here. This would have to be a 1. And then you can't have these two cells add to the requisite. Oh no, it has to be 9. So it could be 2, 1, 9. That could be like, well, not 3, 5. Can't be 2, 6 either. Okay, so no, that was correct logic. It was just not for the right reason. It has to be 9, 2, 8. And then this has to add to 9, which it can't, which means a 2 can't go there. 2 has to go here, which means that's a 5. Cool. So this has to give 9. So we got a 2, then 2 digits add to 9, 2 digits add to 9, and 3 digits add to 18. Cool. That's a neat little trick. I like that. So that can't. So 4 can't be here. Can't be here either. So it has to be 4, 5 here. So we've got 2, 4, 5 to add to 9 there. And now 2, 7 adds to 9. So that's covered. Then we have 9 and 18 here. We have 1, 8, 3, 6 are the options we're missing. 1, 2, 3, 4, 5, 6, 7. Oh, and 9. Yeah, so 9 has to be here. Okay, which means since 9 has to be here, this cannot contain a 9. This has to contain a 2. 6. This has to contain a 7. Oh no, because 2 and 7 could be down here. Because it has to add to 8. So you could have 1, 7. And that would work. Okay, there you go. So this has to be a 1, 3. No, this doesn't have to be a 1, 3 pair. The 1, 3 has to be somewhere here. So it's going to have to be split because this is going to have to contain a 1 or a 3. And this has to contain a 1 or a 3. Well, this is going to be 1, 9, 8 or 3, 6, 9. Either or. It's going to be the opposite pairings. Yes, this is either 2, 6, 7. Oh, no, okay, so because it's going to be 1 or 8, or 3 or 6, 6 would be excluded, so there's 2, 7, 8. So, this, yeah, these have to be 2 or 7. So 2 can't go in any of those spots. Cool. That was actually a helpful bit of information. This can't be a 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this also has to be 6, 7, 8, 9. Hey, it's a quadruple. Which means these must be the low numbers. Which means there has to be a 5 here. Okay, so now if we have 16 minus 8 minus 5, then the other two values could be 3. If any of them bump up, then they have to add to 2, which we cannot, or well, it's 5, 4 something, sorry. Which means we either have a 3 or a 2 as our extra value here, but 2 has to go there, so it has to be a 3, so it's 5, 4, 3. 3 and 4 plus 9 give us 16. Yeah, because it could have been, or wait, was that correct? Okay. Let me do that again. There has to be a 5 here. 8 plus 5 gives us 13. So if it's 3, 4, 5, that has to be an 8. It has to be a 3. Yeah. Okay, so since it has to be a 3, this is like this. It has to be an 8. Because an 8 plus 3 plus 5 gives us the right number. Yeah, okay. So I'm going to remove the, whoops, the 5 from there. There we go. Now we have the correct values placed incorrectly. So we know that this can't be a 3. This has to have a 1. Okay. And now since we know that this has to add to 18, it means that this has to be 8, which means 6 can't go there. Which means this can't be an 8. Which means, there we go. We've now officially separated this correctly. We know that this has to be a 0, has to be the 0, 4. This is going to have to be a 1, 2 pair, which means this can't be a 1, 8, so that's 3, 6. Which means this can't be a 6, this can't be a 6. 2, 6, 7, this can't be 6, 7. There we go. Progress is being made, whittling away, little by little. 8 can't go here, which means that has to be a 9, which means... Where did I put 9 in this box then? Did I do that wrong? Yeah, because that has to be an 8. Oh, sorry, that has to be an 8. What am I doing? That has to be an 8. Yeah, there we go. That's what I... Okay. Phew. I was like, something went wrong mentally, and I don't know what I did. But I figured it out. Okay. Whew. I've had a bit of a brain fart there for a moment. So we know that that's the digit problem, that's the digit, that's the digit. We don't quite know how they sort up, but we know that this adds up correctly. So let's verify. 6 plus 9 plus 7 plus 1 plus 2 adds 25. Perfect. That's 25. That adds to 4. That adds to 36. This adds to 9. This adds to 25. This adds to 16. And now we can continue rolling. So we know that there's a 4, a 2, 4, 5, 9 that we've worked on. Okay. Three and 6 had to be somewhere in that row. 3 has to be paired. To be paired with anything if it's a 0, of course, but 3 has to be paired with 1 or 6. 6 has to be paired with a 3, and that's it. Since there has to be a 6 here, either the 6 is the 0, or it is paired with 3. And 3 either is the 0, or is to be paired with 1 or 6. So if 3 is paired with 1, then 6 is the 0. If 3 is paired with 6, then all bets are off the table. And 3 paired with 6 works. Okay. What about this? That's kind of crazy. What's the highest you can make this sum? 9 plus 6 plus 5. So you can make it. So this could equal 25. Or 1 plus 2 plus 3. 6, which means that could be 36. Is there a way I can make that add up to 9 exactly? 1, 2, 6. Then that adds to 36. So 36 or 25. Either or. That's... Yeah, you know. Yeah, this is a little weird. I'm not sure where to move from here. Well, we know that this isn't the 0 we're working with. Neither are any of these. So it's either this or one of these. If it's this... Well, actually, if it's this, what do these have to be? It has to be 4, 5. So that's it. That has to be 4, 5. But I don't see any issue with that. Yeah, I don't see any issue with that whatsoever. Hmm. It's gotta be another. So, like all this information is vertical. So I don't know. Like, all the information in the first three columns are all vertical information. All of our pairs that we have are all vertical pairs. So we don't really have much to go off of. Well, if we did 1, 2, 6 like that. Yeah, then this would have to be. Then that would have to be the green. Because if it's 1, 2, 6. Yeah, so yeah, 1, 2, 6. This adds up to the right to exactly the right number. That would have to be 25 from 36, and the 9 would have to be it. Otherwise, if it's 1, 2, 3 is also a thing that we could do in order to. Yeah, if that was 1, 2, 3. No, 1, 2, 6 with this would give us the right number. Yeah, so if it's 9 plus 6 plus 5, the highest possible value that this could be, this is the only way that could add up to be 25, is if these are the highest possible numbers it could be. But if that's the case, that has to be green. So if it's 9, 6, 5, that has to be the green. But it can't be because it's a 5, which means this can't be 9, 6, 5, which means that can't be 25, which means that adds to be 36. Okay, so we know for a fact that adds to 36. Or yeah, whatever sum it is, with the negative, it has to be 36. Because if it was 25, oh, it could add to more than 25. Yeah, so this isn't 965. That's all that we know. So if it was 964, then we could have the 1 be in here, and that would be 26 minus 1 is fine. But for 36, if 36 had no mistakes, and this has to add up to 9, which would be 1, 3, 6. Or 1, 2, 3. So this, let's just assume that this is exactly a square. Then that has to be the 1. It has to be 2 or 4. So yeah, 1, 2, 6 would absolutely work. Dang. Oh no, this can't be green. Because it's adjacent to this. This needs to be next to a 1 if that was the case. Which means this has to have the green. Which means we can't, if this was 1, 2, 3. That's 39. Which means in order for this to add 36, we need to have the 3. Or one of these has to increase by 1, which you can't. Or one of these has to increase by 2, which has to be a 4 here. So it'd have to be 1, 3, 4 to get us there. And then we have the 1 there. So this can't add 36. It has to add to 25. Okay. I'm just going to do that right now just to show that adds to 25. It's a little screwy. But it's a 25 plus whatever the extra void is. So, knowing that there's exactly 1 void in that row, well, we know what values it can't add up to. We know it can't be 27. Actually, we can compare against the other 3 numbers, can't we? We do this against these 3 numbers to see what values it can be. So, I don't need this anymore, so let's get rid of that. Okay, so, could it equal exactly 25? No, it could be 26 with a 1. It could be 27, 28, 29, 30, 31, 32, 33, 34. Oops. 5. Okay, so if it's 26, then the other values have to add to give us 19. Okay, so 19, and I'll keep going down from there and seeing what those values are possible. So 19, 18, 17, 16, 15, 14, 13, 12, 11. So, can these add up to give us, well, 1, 2, 3. Well, sorry, 9, 6, 5 is the first biggest number we could possibly give. That's 15, could go up as high as 20. 19 is doable. Instead of 9, 6, 5, it could be 8, 6, 5 or 9, 6, 4. Those are doable. Can I go down by 2? Yes. It would have to be, instead of 9, 6, 5, it has to be 8, 6, 4. Could I go down by 3? Yes. And it would be, instead of 9, 6, 5, 9, 3, 5, which isn't doable because there can't be a 3. There can't be a 3 in there because this is the 3 that's excluded. So then it has to be 9, 6, 2, which is doable. 29 means it needs to be 16. Can we go down by 4 from the max? Yes. But now we can go a little bit screwier. Let's build back up from the very bottom then. Okay, so let's do, can I get 11? 1, 2, 3. I can get 1, 4, 6, which is fine. So I can get most of the values here. Yeah, I got a lot of different ways to make these numbers work, unfortunately. This isn't incredibly restricted. I was hoping it was going to be more restricted, but it really does not seem to be. Well, oh wait, this can't be a 2. That changes things quite a bit, so it means they can't have a 3 there. Okay, let's go back and try that again, now that I know that can't be a 2. 16 is 4 below the maximum, which means it has to be a bump down by 1. So instead of 9, 6, 5, it has to be 9, 3, 5 minus 1. So 8, 3, 5, or 9, 3, 4. But it can't be 9, 3, 4 because we can't have a 4 in that area. Okay, let's go back. Let's keep doing this line of logic. I like it. 5 below means that both needs to be knocked down by 1 until we get that. Yeah, it'll be like this for a while. So 9, 6, 5 becomes 8, 3, 4. Can we get down by an additional 1? I don't think so. We could drop down by, we dropped down by 6. No, we can't drop down by 6. Because the lowest we can go is 8, 3, 4. It gives us 15. But the next one below that would be 1, 6, 5, which is 12. So we can't do 7 or 6 as our missing number. So the next one would be 1, 6, 5. And then when we have 165, it has to be 164 as our last missing number. Okay, let's make sure I'm not duplicating any numbers that I'm not allowed to have here. I can't have a 2, 5, 4, or 9. 5, 4. So 2, 5, 4, or 9, which means our missing number is 1 or 8. Holy shit, we barreled that down quite a bit. Which means that there has to be a 1, 8 here. That has to be a 9. Or no, it has to be a 1 or 8, sorry. Yeah, it has to be 1 or 8. So with these situations, we have, so there has to be a 1 or an 8 as our missing number in one of those, in that. That narrowed it down significantly. Holy shit, okay. It's a lot better than I thought it was going to be. If it is a 1 that we're missing, then this is either 865 or 964. Or it's 165 if we're going, if the missing number is 8. But no matter what, that's a 6. Which means that's a 3. Which means that's a 5. Which ones can we have 6, 5 for? Either of them. It can either... So it's either 8, 6, 5 or 1, 6, 5. Which means that can't be a 9. So no matter what... Yeah, the other one has to be in there. And it has to be the opposite. So whichever one this is not is this. Cool. So you have 865 or 165, which means we now know all the other digits there. Cool. That was awesome. That was a pretty good way of getting some digits through just slowly experimenting and knocking down digits one at a time all the way down. Brutal, but let's just double check that this works. So we have 45 minus 6 minus 5, and then no matter what, it's going to be subtracting 9 off of this, because it's the 1, 8, and whatever the other 1, 8 is in here. And that adds up to 25 exactly. Cool. So we have 1, 2, 3, 4, 7, 8, 9. We only have one of the 1 or 8, so it'd be 2, 3, 4, 7, 9 we guarantee to have here, and then either a 1 or an 8. Which brings us either... Yeah, which, number that we're excluding. Cool. That was a pretty interesting endeavor. I did not expect it to actually be that screwy. Yeah, so, given that, now that we know that 9 can't be our 0, and 4 can't be our 0, then the only other single-digit 0 we could have... Well, no, we could have any other single digit, but... Like, oh, yeah, that actually doesn't make a difference. I was going to say, the only other single-digit 0 we could have would be, like, 1. But that isn't correct, because, it could be any number. If it's a 0, it could just be sat right in the middle. It makes no difference. But this does actually have to be a square. So that does actually have to be 149. Because that we know that it's not a that's not a fake. This could be a fake. This doesn't have to be 149 yet. This looks a little bit too symmetrical for my liking. So I want to play here. This could be a 4-5. And then that could still be a 0. But I don't like it. I'm trying to figure out what else... What else to do here? Like, I don't see how to continue. I mean, oh, that can't be an 8. You know, that's gotta be an 8 there. That can't be an 8 anywhere here. Does that tell us anything? I don't think so. I don't think that the values we have actually tell us very much. Oh, wait a second. Do I have any numbers excluded? I don't. Of course I don't. Because that'd be convenient. But because they're all vertically unique already, then getting numbers doesn't actually tell us anything. We don't have any more dots here to help us. So, how many worlds are there that allow this to not have any of the bad numbers in it? That's the question I'm going to be asking right now. So, given this, we have this area. What 3-digit pairs sum to a square and have consecutive digits? 1, 2, 6, 2, 3, 4. And then above 9, we have to go to 16, which means you can have 3, 4, 8, 4, 5, 6. No, 4, 5, 7. No, it's not 4, 3, 8 then. It's 4, 3, 4, 3, 9. 5, 4, 7. 5, 6 is 11. We already have... Yeah, so 5, 6 would be 11. get us to 16, we need another 5, which we can't do. We get it to 21 to 25. No, we can't. 6, 7 is 13. So we could have 3, 6, 7. 7, 8, 1. And 7, 8, 9 gives us 24, so that wouldn't work. Which means the pairings we're looking at is 1, 2, or 2, 3, or 3, 4, or 4, 5, or 6, 7. So you skip 5, 6. The 6, 7, or 7, 8. What's the excess number? 6, 4, 9, 7, 6, or 3, 1. That's a bit annoying, not gonna lie. That isn't very helpful. 1, 3, 7. Yeah, it's 1, 3, 7, 9, 4, 6. So 1, 4, 9, 3, 6, 7. But uniquely, only 1, 2, 6, and 2, 3, 4 get us to 9. Is it gonna be more summation shit? Could be. Okay, so 1, 3, 7, 9, 4, 6. Okay, so we know that those are the only values that can be here. What values can't go up there? Well, we already knew that 8 can't go here, unfortunately. But if this is a 1, then 8 goes here, 7 goes here. This can't be can't be the number we're looking for. Okay, wait. So let's just get rid of that. Doesn't really matter. This can't be a 0. Neither of those can be a 0. Because if it's a 0, it has to be next to a 1. 0, 1. This could be a. Oh no, it could be a 3. Let's say it can't be an 8. Makes 9, but it could be a 3. If it can somehow deny that from being a 3, then neither of these could be the number we're looking for. And then this is either 4, 5, or it's a full combination. Oh man, we don't have very much to go off of here. Let's suppose that none of those are. We could do 1 plus 2 plus 3 plus 4 plus 5 makes 15, so 16. Anywhere from 16 to 9 plus 8 plus 7 plus 6 plus 5. 35. So can't be 36, which means down to 25. So it's 16 or 25 is the sum that we're looking at. Could that sum to 16? If there's no... It could. And then that would have to be an 8. Actually, 16, 8 makes 1 plus 2 plus 3 plus 4 plus 6 plus 8 means 5, 7, 9 have to be up here. Is there any combination that allows 5, 7, and 9 to be? It have to be 5, 7... No, 7, 5, 4, and 9. So yeah, if this isn't any of that, then yeah, if this just doesn't have the number, and it adds to 16, adds to 16, Then 1 plus 2 plus 3 plus 4 plus 6. It has to be. Which means 5, 7, and 9 have to be in the top here. And that has to be 7, 5, 4. Well, okay, let's just quickly humor it. Well, what does this add up to? Sorry, this is right. It's not 5, 7. So that should be 4. Yeah, that's 16. That's 9. That can't be 9. Because then that's 9. And 9 has to be the value in here. Which means if this does not contain the value, it cannot be 16. Which means now we have to prove that if it does not contain the value, it cannot be 25. That's the next problem, which is going to be a lot harder because it's the perfect average in the middle of all those numbers. It's very irritating. That's what we got to do. So yeah, this cannot be an empty 16 sum. So is there any way to force it below 25? And if so, what needs to be done in order to force it to be below 25? So what examples of things would bring that? So let's say it doesn't have the value. So it adds 25. Let's just say for the sake of argument that that's the value to make things easy. What do all the other values have to add up to? They have to add up to 20. So you have 4 values that add up to, or actually it could be, yeah, let's say it's any of these. So it has to add to 20 or more over 4 values. 9 plus 8 plus 7 plus 6 gives us 30. So you have 10 degrees of freedom and restrictions on those 2 values. So 20, those values, yeah, so if we're working with 20, no, I don't see anything that I can work off of right now. All we know, okay, so we've established a little thing, I guess, that cannot be 15 and not contain the 0. But I don't... like, this box is going to be the one that tells us where this goes. I was going to say, oh, man, if one of those cells told us something, then we might be able to work with it. But here, we just... yeah, unless we can figure out where the 9 goes, but the 9 we can only place via information from this cell. Because the 4 9s are both there as well. Well, we know that there has to be a 4 9 here. Because if there's... no, we don't know that, do we? Well, that can't be a 9. So the 9 has to be here. In this box. Which means there has to be a 9 here. Period. So there has to be a 9 there. Which obviously tells us, I guess, that it can't be a 25. Oh, sorry, that can't add to 16. But could it have to be 25? So if it was 25 minus 9, we have 4 values to add to 16. We have 6 degrees of freedom to do that. We do have enough to figure that out. That's 1 or a 4. 9. Means we can't have 9 there, but we already knew that. If that's a 1, then that's a 1. Wait, if that's a 1... no, we don't have any restriction on guaranteeing that there's a 1 somewhere in that row. So it's either a 1, a 0, a 4, or a 9. We know that for sure. What values do we have left over for our randoms? If it's 1, 3, 1 and 3, and then 6 through 8. 1, 3, 6, 7, 8. Okay, so what could this sum up to if it has the block? Well, if it's 15, there has to be 1, 2, 3, 9, and the number, which is doable. Fuck. Dude. I did not think it was going to be this difficult. Well, I mean, if this was 1, 2, 3, 9, it could be 1, 2, 3 down here. I was going to say there had to be 2 up there. Like, oh, 1, 2, 3. And then we could make a triple that gives us a 4. That's something. But it doesn't even, because we could just put the 1... Oh, no, we can't put 1, 2, 3 down here. Given that, there has to be 2 up there. Okay, so if it adds to 15, then this has to be a fake. Like, in the entire box. Like, it has to be that. If it adds to 15. Because if it adds to 15, they're looking at 1, 2, 3, 9. That would equal a 4. And then this would be 2, 6, 7. Ah! Okay, so here's our issue. No, there had to be an 8 here, rather. That's what it would be. Yeah, that would be 6, 7, 8. Which is okay. Damn. Well, that doesn't give us anything. What did it give us? Given us anything? Would it be the 8 would need to be down here? Ah, crap. I don't see where to move on from. I don't see how to continue here. Like, I feel like this is what I need to do. Something with, it adds to 36 or more. Or 20, what could it be 25? If it's 25, so yeah, let's just say that the sum is looking for is 25, and the highest we could have as the alternate would be 8. It would be 33 plus 9 plus 7 is the highest we can go, 49. So you have 4 degrees of freedom if it is 25. And those degrees are kind of irritating. Can this be a 1 and not a 0? If that's 25 plus 9, or well, plus 8 is the highest, plus 1. It wouldn't work. So if this had the 0 and was added to 25, that can't be a 1. Okay, what about 36? You have 36, and that was a 1. And then it would be as 2, which would make that 6. So this could have the fake being a 2, that could add the 1. And that would be a 6 minimum. I mean, that's something, I guess. But it's so, like, minor something that I'm thinking that's just not correct. Maybe I've got to look up here. These are all... Oh, those all have to be different ways of getting squares, don't they? What squares can we have? We can have 1, 4, 9, 16. It could be 1. It can't be 16. Because 16 would have to be a 9 and a 7. So they have to add to 1, 4, 9. Yeah, so they have to be 1, 4, 9. Because 1, 4, 9, 6... Oh, no, they could be the same square, just done differently. So it could be like a 4, 5, and a 2, 7, or a 3, 6, something like that. So we know that we can't have a 2, 7 here. But we could have... Well, let's see what various numbers we can think of. Could be 1-8. The other 1-8 would have to be down here. And that will be the other, that will be the other somewhere here. Yeah, okay, that works. So, could be 1-8. Can't be 2-7. Could be 3-6. Could be 4-5. That's if it adds up to be a 9. Adds to be a 4, it has to be 1-3. So, for the cells that don't have any voids in them, if there are no voids, then this has to be 1, 3, 4, 5, 6, 8. And then that would have to be a 2. And that would work. And we could have a bunch of 9s all added up. 1, 8, 3, 6, and 4, 5. And then that will be the 9 to finish off our row. So it does actually work, unfortunately, in a nice, even way. Actually, 1, 8... 1 or an 8 can't be here. So the 1, 8 would have to be here. So we have 3, 4, 5, 6. Eight can't be there. So it would have to be here. Oh, sorry, wait, this is... Yeah, 3, 5, 6. So yeah, this should... We remove the 1, 8 here, sorry. If this could be 3, 4... Well, so yeah. Since 4... Wait, 4, 5 has to be together. Which means that can't be 4, 5. Yes, it can be. It could be 4 or a 5. One is 4, 5, one of them is 3, 6. Whichever one that is the opposite of it. So this absolutely works. If none of these have, if that's the green. But we still don't know that that's the green, but it doesn't cause a contradiction. That has to be the other 1, 8. There has to be another 1, 8 down here. And something down here is fake. And something in here is... Well, we already know that one of those in there is fake, but... We know that the 1, 8 that's in here is fake. Oh, the 1, 8 in there is fake. Which means the 1, 8 that we put here wouldn't be fake. Ah, we can't put a 1, 8 anywhere down here. So wait. So we have 1, 8. There has to be a 1, 8 here. At least one. If this is correct, then this 1, 8 implies that no more 1, 8s up here. There has to be at least 1, 8 in here, but one 1, 8 in here, so it has to be there. And that means that there has to be another 1, 8 down here. But if it's here, but yeah, no matter where it has to be paired with another 1, 8. No, it doesn't, because it could be 1, 3. Or it could be green, paired with the green. No, down here, can't be there. This would have to be the 1, 8. And it has to be paired with a nothing. It has to be paired with the green. Because there has to be a 1, 8 here. Which means there has to be at least one 1, 8 down here. But we also know that because of the 1, 8 that's here, that has to be the green in the entire row. Because that's the 1, 8 is the green. Which means the 1, 8 we put here can't be a green, which means we can't put them here. Because this would have to be a 1, 8 pair, which it can't be, and none of them could be green, so it doesn't let the 1, 8 pair need to be there. This has to be a 1, 8, which means this has to be the green. If this works this way. This is still entirely bifurcating off of the idea that this is the green, essentially. If that's the green, then this is the green. So these are the only 2 green cells we can have, which means no matter what, none of those can be green. Because if this is green, this is the consequence of what happens. So those are the only possible green cells. Which means that's 149. So, off this logic, that can't be a 1. That could be absolutely anything. So yeah, let's scrap this. We've learned a little bit more about numbers. Is that we know for a fact that this or this is a green. Which means, yeah, so those are the only two possibilities for this area. If this is a green, then this is completely written off. There has to be 2 greens up in this area. So it could be up here, could be up here. If this is a green, then we know that has to be a green, that has to be a green. Cool. If this is a green, yeah, no matter what this, so yeah, now that we're back to here, that has to be a 1, 4, 9, no matter what. Cool. That has to either be 1, 3, or some matching pair. So it could be 1, 8, which would make that a 9, and that 4, that a 2. That's pretty funny, honestly. I love the consequences of 1s and 8s in this puzzle. But it could also be a 2, 7. Yeah, there's a lot of things that this can be. It can't be a 3, 6, though. Could be 4, 5. Yeah, so this is a 1, 8. Then this would have to be a 9. This would have to be a 4. That would have to be a 2. So 1, 8 guarantees that this is the right row. 2, 7 does nothing. No, it guarantees this is the wrong row. 3, 6. That actually does. No, it isn't doable. 4, 5. 1, 9, 1, 8, 9. Nothing here to speak home about. This is the first time they've actually gotten anything that doesn't say anything. There's got to be a 5 up there. Five and 4. Oh no, 4, 5 would guarantee that this is right. So no matter whatever this is, locks in this as the correct value. So 1, 8. Yes. So let's actually write that down. So in that cell, 1, 8 makes it a yes. 2, 7 makes it a no. 3, 6 isn't doable. 4, 5 makes it a yes. So any restriction in this cell tells us something significant. This adds to 25. This adds to 9, and we know it does. That adds to that. We can figure out what these cells that add up to within some degree of reason. So if this is 1, 8, that's 9 plus 9 plus 4 plus 2 means that plus 3 means all of these cells add to 27, which means the other cells add to 18, which means that has to be a 9, which it can't be. That can't be a 1, 8. So that's a 1, 8. Then we have 1, 8, 9. 1 plus 8 plus 9. Plus this is a 4. Plus this is a 2. Plus this is a 3. Which means the numbers we have left over, knowing that this is a 2, that has to be the green. These have to be legit. That can be... this could also be a 1, 3, but we're just going to discuss 9s. So minus 45 means it adds 18. So this has to be 9 and 9. Or it could be 16. No matter what, there has to be a 9 somewhere in there. We already have our 9 locked in. Which means that can't be a 1, 8. Okay. So we also have to consider a 1, 3 pair, which is another thing that we have to think about. If it's a 1, 3, does it give us anything? It gives us absolute... no, it can't be a 1, 3. Yeah, it can't be a 1, 3, because there's a 3 there. So, it can't be a 1, 8 pair. Could it be a 4, 5 pair? That's 4, 5, and that's not a 4. That's not a 4. Then we have, again, guaranteed 2 here. Meaning that has to add to 9. So we have 9 plus 9 plus 3 plus 2 is 23. So that's 23, which means the rest of the cells have to add to 22. Well, then that can't be a 1, so that has to be a none then. So then, whoops, sorry. There you go. Which means these cells have to add to 13, which means that can't be a 1, which means that is 8 or 5 or 9 or 4, which isn't doable. Which means that can't be a 4-5 pair either. Which means it has to be a 2-7 pair. Which means that is a 4, that's the 2, that's red, this is the one we're working on, and we've now and we can continue the logic that we had here. Here has to be the 1-8, the green has to be somewhere in here, this is a green, and the rest of these is history. Let's go! That is good work on that logic. Holy cow. That means that this has to be a 9. Which means that's a 1-8 pair. There has to be a 1 or an 8 somewhere in there. So we've got 3. Well, wait, given that this is a green, this has to add up correctly. So this is to be a 1, 4, 9. This has to be a 9. That has to be a 1. That has to be an 8. That has to be a 1. Okay. And now, given that we know that's a 1, 165 means that the 8 in here is the fake. So there has to be an 8 in here. Yep, and that's all we need to remember. So there has to be an 8 in there, and the 8 is the 0. Okay. Progress. 4, 5, 9... 2, 8, whatever the hell that is. So, given this, it can be 4, 5, 2, 9, 8. Can't be a 1. So the 1 has to be somewhere in here. But yeah, 3, 6, 7. Can't be a 3, can't be a 7, so it's got to be the 6. That's the 6. Okay. Whew. Which means that, which means there has to be a 6 up here. If it's here, that's a 3. If it's here, then there's a 3, 6 somewhere up here. Okay. So one of these is a 6. There's got to be a 9 in there. One, 2, 3, 4, 5. Which means this is either a 4 or a 6. Let's look at the options that I had before for consecutive. 4, 5. Ah, you can't be 5, 6, because 5, 6. Well, it could be... Well, that's assuming that this isn't it. But this can't be the 0. But it could be 5, 4, and that could be a 0. So that is an option. We have that as a possibility that we have to consider. There has to be a 2, 7 in here. 1, 2. Where's 3 have to go? Can go anywhere. 4, 3, 4 can go anywhere as well. So it's 8, 9, 3, 4. 2, 7, 3, 4. 2, 7, 3, 4. And that's correct. That can't be a 2 or a 7. Has to be a 3 or a 4. So now we have 6, 6, 5, 6, 5, 3, 4. Okay. So these have to add up to 9. Which means if this is not a 5, then a 5 has to go here. which means that the 6 not good there. If this is not a 6, so this can't be a 3 or a 4. Because this was a 3 or 4, yeah, that doesn't match properly. So it's 5 and 4, 6 and 3, which means other way around here works fine. We already know that this is how that works. Okay, this is the opposite. So next to 5 and 6 would be a 4, 5, or 6. So that can't be a 3, which means this can't be a 6. Okay, so this could be a 5, 6 there. Yeah, it could be 5, 6. Oh yeah, and these are all red. So let's just dye the fucking colors while we can. So this could be 5, 6, 3, 4, and that would work fine. Whatever's missing will go in there. Okay. Whew. Progress is being slowly whittled away. And 1, 8, 9. Yep, and these are now horizontal. These are all horizontal informations, which means we now have a bunch of verticals there, a bunch of horizontals there, and all we have to work on is that spilling out here, is essentially all we can do. Does this have to be... No, it can't. If it's 5, 4, then this could still be a 7. So, if it's 5... Yeah, it could be... Wait, can this ever be a 6? Makes 11. That can't be a 6, that has to be a 4. Which means that has to be a 9. Which means that has to be a 4. Which means those have to be red. Which means that is green. Okay. And that can be literally anything. Okay. We'll figure that out in a bit. This is red. Which means this actually does sum up to 25. And we knew it did. Okay. 25 plus 4 makes 29. Which means these all have to sum up to 16. Just that sums up to 16. Which isn't a lot. What values can we have here? Can't be 6, can't be 2, can't be 5. Can't be... That's to be the 8 that's up there. Can't be 4. 1, 3, 7, 9. Can't be the 9. Has to be 1, 3, 7. Okay. So given that we know that the rest of them add up to 16, this could be a 1, then a 7, then a 7, 8. Or a 5, 9. Okay, it wouldn't be 5, 9. It would be, this wouldn't be a 9, this would be a 5. Okay. That is one of the options that we have. If that's a 1. Those are all the options that we have. Oh, this can't be a 9. Which means this can't be a 5. This can't be 8, so this can't be 7. But otherwise, this works out. So if this is a 1, then it has to be 7, 8 there. Okay. I'm actually going to quickly remove this. Move the 9 from there, just so I can keep everything clean and remember where everything has to be. This doesn't have to be 2, 7. I don't need the 5, 6 reminders up here anymore because I've numerated them. Okay, so if this is a 3, then I have to add to 13. How do I get to 13? Well, it can't be 4, 9. But it could be 5, 8. It would have to be 5, 8. It could be 6, 7. 6. Whoops. So yeah, it would be 5, 8, or 6, 7. Okay, so now this is a 7. Then it needs to add to 9. 1, 8 is fine. So it's a 1, 8. Then it could be 2, 7. No, it can't because that's a 7. 3, 6. That would be a 3, 6. 4, 5. Which can't be 4, 5. So that has to be an odd number. That has to be a 6, 8. Interesting. That's a lot more restricted than I actually anticipated it being. Yeah, we know these guys have to be 9s. There's actually a heck of a lot more restricted than I thought it was going to be, which means 1, 2 has to go here. 4, 5, 6, 7, 8. So then the other of 6, 8 has to go here. So if we know that that sums to 25, which we know it has to, 25 minus 2 minus 9 gives us 14 in 3 digits. One of which is even, 2 of which are odd. So we have a 6 or an 8. So let's work with 8 first of all. If it was 8, then we need to have a 1 or a 1 5. That'd be 7 3. 3 6. That works. Okay. Okay, yeah. So this would add up. So I'm just going to remove the middles here. Okay. This is 6 8. None of these can be red. None of these can be red. Cool. Okay. Progress is being made. We know that this has to add up to a square number. 25 minus 8 gives us 17 in 2 digits is not doable. So this can't add to 25. Because if it added to 25, minus 8... Yeah, so this would be like... You want it to be big numbers. Yeah, that's not doable. So this has to add it to 16, or it could be 1 2. 1 2 6 is still in the mix. So let's put in 1 2 as a possibility. Alternatively, we do 16 minus 6. Oh, it's just 10. Yeah, it could be fucking anything there at that point. Can we put a 4 in here? I don't think we can. Because it's either 6 plus 4 makes 10 plus 6 gives us 16. Or 8 plus 4 is 12 plus 4 is 16. 4 can't go there. This has to have the 4. Which we already know, is legit. That's fine. What numbers are missing? Is it really 1 3 7 that's missing? 2 4 6 8 5. Yeah, 1 3 7. 1 3 7 is missing. So any numbers that can't be 1 3 or 7 can't be green. Do we have any info about that? We don't. Well, we know that 2 digits could add up to 16. It was 9 plus 7. Yeah, 9 plus 7 would absolutely work there. Ah. What does this add up to? Well, we know that it's 16 minus 6 is the highest that could possibly be. Then this, we assume it adds up to 9, but it could add up to 16, plus our extra void, which could be up to 7. Means this is a minimum of 12. It's a minimum of 12, which means this is a minimum of 4. No, that's a maximum of 4. If, yeah, so it's 4, 3, 2, 1. But it's possible if these numbers offset by enough by 4, so this is like a 5. No, it can't be a 5, but something like that is offset. So like offsets by 2, offset by 2. So this is the 7 that's missing, or something like that. Yeah, offset by 4, because we had the 7 missing here. Let's say it's a 3 that's missing instead. Then that could be the missing number, and then this would add up to 16. Well, I've got to hop off now. I've spent 2 hours now working on this puzzle, give or take. I'm going to come back in a bit, but oh man, this was a lot crazier. A very, very interesting puzzle. I've had a lot of fun toying around on it. But that's a 6, and that's a 6, and 6 has to go here. It had to be 6 and 3. Oh man, I'm just getting so if this is a 6, and let's suppose that this is a 6, then 6 has to go here. Where 6 has to go somewhere in this box. Can that ever be a 6? 6, 8, 6. Yeah. There's no reason why it couldn't be. So then this has to be 6, 3 something. That has to be a 2, 7. No, still no issue. I have a feeling that we're gonna like slow, like the fact that we've started like down here and like slicked up the board. Like we've just gone in like a slow circle around here, like in this shape. I have a feeling that once we've tackled this tile a little bit more, I'll be able to tackle this tile a bit more. And then once I tackle this tile, I'll be able to tackle this tile a bit more. And then I'll be able to tackle like slowly progressing up like this. And I still know nothing about the greens here. You'd think I would have learned a little bit more about them, but I just haven't gained a single friggin' thing. And here I mean, there has to be a 4 somewhere in that row, but that doesn't tell me what the actual value is. 5 can't go here. One, 3, 5, 2, 6, 7. Ugh. Gosh, this is, I mean, like, you know that this has to be green. So the hidden zeros don't repeat in the cage thing. We've already essentially finished that aspect of the puzzle. There's nothing else here about repeating in a cage that could possibly affect us. But if that's a 4, then that's a 4. Then that can't be a 4, but that could be a 4. 6, 3. Okay, wait. 4, 5, 6, 3. If I could somehow make that a 3, then I could exclude a value from down here and then start actually making progress. If it's a 4 or a 9... Yeah, so this is 1, 4, 9, 3, 7. Those are the only possible values that can be, and it could be still be a 0. Could this box have a 1 as its value? 1 plus 9 plus 16. So this heads to 26. That could add up to 36. So let's do plus 36. This has a maximum value of 62, which is 17 degrees of flexibility. But no matter what, that's correct. So you have 17 degrees of flexibility. We could knock off 11 if this was as long as this is red. We know this is either 25. No, it could actually be 16, can't it? 1, 2, 3, 4, 6. God. Yeah, I've got to head out shortly, so... damn it. This puzzle is going to be left incomplete. Which is quite frustrating, honestly. Okay, let's go back to the considerations I was saying about before. Let's suppose that's a 9. Then we have 36. So yeah, everything else here adds to 36. So ignoring whatever the heck means that this has to be, well, I mean, minus 7. So yeah, if this is a 9, then everything here adds to 36. Which means, regardless of what the thing is, this would need to have the green in it. So if that's a 9, the green has to be here. And you can't go down to 16, so it has to be 25. Which means the green plus this adds to 11. Can't have a 9, so it's got to be 8 and 3. Or 7, 4. Can't be a 4. Can't be an 8, which means that can't be a 9. Okay. Or, well, it still could be, like, it still could be a 1, 3, 7. So now, could it be a 4? Okay. Okay, knocking that off of being a 9 feels pretty freaking good, actually. Being able to actually start whacking away progress. So, 45 minus 7 means that this adds all up to 38. Which means this could be a 2, and this would work. Yeah. If that's a 7, that could be a 2. And there's no issue with that being a 2. So if that's 7, that's 2. Which means 2 would need to be there. It would need to be one of these 2 places. And 2 couldn't be there. So 2 would need to be here. So 7 I don't see any progress with. Could it be... Well, if it's a 1, 3, or a 7, then it has to be the void number. So if you have 45 minus... Yeah, minus 7. You have 38, so this has to be a 2. So that's 7, that's a 2. So let's mark that down, as that's the first possibility. If that's a 4, 45 minus 4 is 41. That could be it, but we still need this to add up to be a nice round number. So that would be 5 is the number that we need to consider. So it could be 1, 2, 3, 4. So it would be 1, 3. So yeah, it's either this is a 5, so this could be a 5 and it'd be fine. Or no, it could be a 5. So that's a 5, and that has to be 36 exactly, so it can't be a 5. Yeah, because this is considering it's a 4, so it can't be a 5. Which means, if it's outside... It can't be outside. Okay, so it needs to be inside. Which means you need to have 4, 3, 2, 1 be the possible goods you have on the inside. So it's only 3 or 1, and they have to add to 5 to total. So this is either a 2 or a 4, and it can't be a 4, so it still has to be a 2 anyways. Okay. So... if it's a 7 or a 4, then that has to be a 2. Interesting. What if it's a 3? 45 minus 3 gives us 42. If it's a 3, then it has to be a green, which means we need this to equal 36, which means this would be a 6. Okay. If that's a 3, that's a 6. That's a 5, 4, 6, 3. Can't be a 3 here. That can't be a 6. Because if it's a 3 here, then that has to be a 6, which means that has to be a 5. 5 has to pair with a 4 there, which means that has to be the 6-3 pair, and that 3 lines up. Which means it has to be a 1, 4, or 7. Can it be a 1? 45 minus 1 is 44. And if that's what it has, then it could be a green, it could not be a green. But let's consider the possibility of it not being, of it being red first of all. Then we would need 8, 7, 6, 5. Oh, let's consider it being green first. Then we would need this to be an 8, which it can't be. Which means this is either a green 1, 7 or a red 4. If it's a 4, 7, this has to be a 2. So now, if this is a 1, and it's green, then this has to add up. Yeah, if it's a green 1, then this has to be an 8. So that's a 2, 8 pair. It can't be an 8. If that's a green, so it has to be a red pair then. Yeah, it has to be red. The green has to be in here. So yeah, it's either a red 1 or a 4, or it's a 7. Okay, so it's either red, 1, 4, or a 7. Whew. So if it's a red 1, then we have 44 to work with. Then this plus this, so the green that's in here plus that has to add up to 8. Which means 3, 7, that's either a 1 or a 5. Those are all the possibilities of this. And it can't be a 1, so it can't be a... So if that's a 1, then that's a 5. So it's either a 1, 5 pair, which makes that a 6, which makes that a 3, which makes that a 5, 4. If that's a 1, that's a 5. Otherwise, it's a 2. So we have a 1, 5 pair. I'm going to write that down. But middle box. 1, 5 or 4, 2, 7, 2. 1 is red. So yeah, so this is either... So no matter what, that can't be a 1 then. So one of these has to be a 1. Because this is either a 7, that's green, or a... Oh no, it has to be 3. Yeah, so then either the 3, 5 is in here, or the 7, 2. Wow, that's so much more restricted than I anticipated. Is there any world where that's a green? Well, yeah, we don't know whether that's a green or not, but it could be a red. All we're saying is that one of these is green. So if that's a red 1... yeah, so this greeniness doesn't exactly matter. I think that that's correct. Yeah, now it's officially 6, so my ride's going to be here any minute now. So I have to head off, and I will finish the rest of this video in a bit. Okay, I'm back. I still have a little bit more work to do, but I'm not sure exactly what to do. I'm kind of at a bit of an impasse here. I'm not sure how to make headway. There's probably something incredibly obvious that I'm missing. I just came back, looked at the puzzle for another minute, and then turned on the camera again, so there's probably something incredibly obvious that I'm missing. I just can't think of. So if this sums to be 25, and then plus 4, then minimum plus 6 plus 1, then I'm missing a 9. So that had to be 8, 1, 7. 8, 3, 5, 6, 7, 3, 6, 7, 1. Well, it can't be 8, 3, 3. That's something at least. This is tricky. I don't really know how to move forward from here. There's probably something painfully obvious that I just don't see. Yeah, there's probably something painfully obvious that I just don't see at the moment. Gotta put a little bit of thinking grease on. Because I don't know... I don't see anything obvious. Well, maybe it's the summation of this. Or this. Well, this has to make a square. That has to make a square. And 2 of these values have to make a square. So 45 minus 6 minus 2 is a minimum to make 37. No, that's not right. It's 45 plus 6 plus 2 makes 53. I need to add another. So this is 3 squares added together. Can I get 53 to do? Oh, but then it has to be subtracting the green, which is 1, 3, or 7. So I could have it either be... Oh, and then this could also be a green. That's a dead pathway to explore. Oh, these are the same digit. I'm actually just blind. That has to be a 1. Ugh. God, that was stupid of me. Can't believe I missed that. That's pretty bad. So, Let me know that 5 has... Oh, I just realized now. Yeah, one of these has to be a 5. 3 doesn't have to be there. 4... 8... Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that for sure. One has to go somewhere here. And one of these. Either that or wherever the green is in here. So it has to be a 1. So it's possible that's it. So you have 1, 3, 7 left. Well, let's do the sum. 25 plus 1 plus 4 gives us 30. So if I have... Which means the other ones need to add to 15. The only way I can add to 15 is as a 7. Two, 3, 4, 5, 6, 7, 8, 9. We can't have 3, 5 there, so that has to be 2, 6, 9. No, you can't have 2, 6, 9 there, so it has to be 3, 5. This has to be 2, 6, 9. This has to be a 7. 7 has to be down here somewhere. Okay. Little incremental steps of progress. So this has to be a 1 or a 3. Crud. Oh, and then we have... Sorry, I just noticed something. This 5 cancels out this 5 here, which means if this sees... Yeah, so this has to be 2, 6, 5. This has to be 3, 5. Which means, like, yeah, okay, so this can't be a 3. Which means this has to be... the 1, 0. Wait, how did that do that? Okay. Weird. Which means that the 3 has to be the void in here. Which is very interesting, because then that means that can't be a 7. So this has to be a red. And then by extension, that will have to be a red as well. The continuations we had a 1, 5 or a 4, 2. So that's the box we're gonna have to work with our 3. So we have 36 plus 3 means we need to add, so it could be a 1 and a 5, or a 4 and a 2. Yeah, so those are our options. It just adds 1, 5 or 4, 2. It just adds to 6. That's nice. Okay. Incremental progress. So 1 has to go in there because the green has to be there, and the green needs to be a 1 because it can only be a 1 or a 3 based on everything else, which means that's an 8. That's a 1. Means 8 needs to go here somewhere. 8 plus 4 plus 2 gives us 14. Let's get to 25 through 11. Can't be a 1, can't be a 2, could be a 3. So 3, 8. 4, 7. We already have a 4. So it could be 3, 8. 5, 8. So it's gotta be, so it's, oh no, it can't be 3, 8. Which means this can't be, oh, but it could be down here as well. Okay, so it could be a handful of these options. Can't be 5, 6 no matter what, because we can't put both of those in there. Can't be 4, 7. Can't be 3, 8. We don't have an 8 in there. So it has to be 2, 9. Oh, we already have a 2 in the box. Which means we're looking for 36. We have 3 more values to make it add to 22 without repeating an 8. Did I fuck up somewhere? Okay. Oh no, but I can also add 3. Sorry, 14 plus 3 makes 17. Instead of 11, I'm looking for 8 if this is a 5. So yeah, I think this has to be a 5. So I need the other values to add up to 8. I mean, 1, 2, 5 doesn't work because you can't put with 1, 2 here. So it has to be 1, 3, 4. Which means, no, but it can't do a 1. Okay, we'll work on this a little bit later. I'm not going to tackle this box quite yet. Something's a little screwy with my numbers. 25 minus 8 gives us 17. So this is either 17, 7, 8, which it cannot be. So it has to be 16. So it just has to add up to 8. So 8 plus a square plus whatever. So 45 minus 8 gives us these cells add up to 37. Minus 1 means these squares minus 1 gives us 36. Then plus 2 or plus 5. So if I do plus 2, then that's 38. Which cannot be the sum of 2 squares. So if I do minus 2 plus 5, 41 is 16 plus 25. So 16, 25. This had to add a 16, which means it's a 7, 9 pair. Because that can't add to 16 because we already have a 4, 8, and a 2 in it. And this does have to be a 5. That has to add to 20 now. So 20 minus 4 minus 8 means the other values need to add to 8. Can't be a 1, 7. 2, 6. 2, 6 is doable. 3, 5 is not doable, so it has to be a 2, 6, which means that's a 2. Sorry, which means that's a 6. Which I mean, to be fair, it was pretty easy to deduce that. And then this is 2, 4, 8. Then 1, 2, 3, 4, 5. That adds a 16. Cool. Okay, so I'm still on track. Which means that's a 1. And hey, it adds up correctly. Oh man, I'm actually going to be able to solve this fucking puzzle. That's a 6. That's a 3. That's a 5. That's a 4. Which means that can't have a 4. That can't have a 3. This has 2 in it, so that can't be a 2. That can't be a 2. This has a 9 in it, so that can't be a 9. This has a 7, so that has to be a 2. That can't be a 2. That can't be a 7. It's a 4, 7. That can't be a 2, so it's got to be a 6, 9, 2. So 4, 8. So this is 4, 8. So 5 has to go over there. And I don't see much else is going to be helpful. Well, actually, we can figure out what things go on both sides. Not quite with certainty, but most of the way there. So 1, 4. So 1, 5, 3 have to all go up here. No, so 5, 3. 9, 7. Yeah, 9, 7. Yeah, so I'll recognize that. And then whichever one breaks this pattern, I don't see what breaks it yet. It's gonna be this cell that breaks that 2-6 pattern. Man, I started with this, and it's not complete. I made, like, next to no progress. That's really weird. So you know that the 3 has to be somewhere along down here. And the 3 is the value that we're examining. This can't be an 8, so it has to be a 2. Which means you need 2 down here. What can this value be? Are we looking at 6, 7, 9? Oh, so that now makes that a red. Oh, what was the value over here? It's like this. Okay. Well, that's unfortunately to be expected. 6, 7, 9 as well. And that's red. All these values are red, which means this value is green, which makes that a 1, which makes that a 2, which makes that a 1. Okay, now I can remove the... Whoops. I can remove that. Four, 8, 6, 7, 9. 2 has to go down here as well, doesn't it? 2 and 3. This can't be a 6. So this can't be a 3, because if this was a 3, then that will be the green. It would represent a 0, and that would have to be a 1, which it can't be. So that can't be a 3. If this was a 2, then this would have to be a 1 or a 3, which it cannot be. So one of those is correct. Let's just remove the red for now. Okay. Oh gosh, my eyes. Let's make this red now to show that those are the those are the zeros. Alright, let's make it blue. Yeah, blue is the zeros. Okay. Don't have any 2s or 3s to indicate anything otherwise here. You know what? I prefer the way it looked before. So, can't be 1, 2, 3. This can't be a 4 because we have a 5 there. It can't be a 6. So you've got 7, forcing that to be an 8. 8, forcing this to be a 7 or a 9. Or 9, forcing that to be an 8. That has to be 7, 8, 9. 1, 2, 3, 4. That has to be a 4. Because 4 can't be on any of these dots, can't be there. Yeah, so that has to be a 4. 5, 6, 7, 8, 9. Okay. That's going to be 6, 7, 8, 9. Okay. Okay. Progress. Little bit of progress. This is a 7, 9 pair. Didn't even see that. That makes that an 8. This can't be an 8, but it still can be a 7 or a 9. That has to be an 8. I didn't even realize that broke. Which means this has to be a 4. But it doesn't actually give us any information. Crap. 8. This gives us a 4. 8. That can't be an 8. That can't be the 8. Which means this is the 8 and 8 is the green. which means neither of these could be green, which means this has to be the 3, which means that's the 2. Since that can't be the green, that's the 9. Okay. Three can't go up there. 5 can't go up here. 5 can't go there. So in this box we have a 5 blocking all of that. This 5 blocks this. This 5 blocks that, which makes that a 5. That can't be a 3. Which means that blocks a 3 there, which means that's a 3. Which means it's a 2-6 pair. That's a 2. That's a 6. That's a 2. So it's a 7-6 pair. Oh, it's not broken, is it? Fuck. Oh, come on. You're so close to cracking, I just don't see. 1, 2, 3, 9. Okay. That's a 7. Six, 9 pair. Oh, sorry, no. That's removed. That makes 6, 9 pair. That makes a 6, 9 pair. But we still have 7, 8, 9 here. Ah, this can't be a 2. So this would be a 7, 2, 6, 7, 9, 6, 9, 7, 6, 9, 7. Holy crap. Two and a half hours. Jesus Christ. That is a fucking puzzle. I had to do it over the course of 2 different days. I just didn't have time. That was an incredible puzzle. I will say, one of the favorite puzzles I've done in quite a long while. I'm genuinely impressed that I managed to solve it. Oh my gosh. That's an excellent puzzle. I hope to be able to do more of these in the future. As always, have a nice day.